Wonderful. That's wonderful. Okay, so what we're going to talk about today is just empowering you all to support your students with addition and subtraction. And I'll cover multiple grade levels. All of the strategies shared today are applicable to every student in every grade level, even into junior high. So I'm excited that we have some parents here today from those grade levels in those schools as well. So again, thank you for being here. Thank you for giving up your time for an hour to focus in on math and join us today for this Parent University session. So with that, I'm going to go ahead and get started. So the first thing I want to show you is an image of typical work that we see when we're working with students in elementary. And what I'd like for you to do is just take a moment and type in the chat something you notice about what you see or something you're wondering about what you see on the screen. So I'm going to give you about 1 minute. If you'll do that for me, type in the chat something you notice or something you wonder. If you're just joining us, what do you notice about what you see on the screen? What are you wondering about the students' work? These are the things we see when we're working with elementary students. All right, Patty, will you share some of the favorite things that you saw or just some of the things that you maybe saw repeated?
I see a lot of people say that this is the way I learned math.
Okay.
So that stands out to me because that is what parents are saying. And a lot of them are saying they didn't carry the one and basically the wrong answer.
Okay. I did see struggle come up. The student is struggling, and I would have to agree. So one of the things that I definitely want to mention here is that this student added more than 20, because 27 we could all agree is more than 20, to more than 30, because we could agree 36 is more than 30, and got an answer that is less than 50. So that's a concern. And like I said, this is something we see a lot when we're working with students, especially in upper elementary. One thing I want to mention real quick before I continue, Patty, we need to record because we've had lots of requests from parents who weren't able to join us. Are we recording? Okay, I just wanted to double check and confirm that we were recording. All right, so we're going to keep going with our goal for this session is to deepen all of our understanding of addition and subtraction strategies to support my elementary student by using flexible strategies. So that is our goal today. And with that in mind, here's our agenda. We're going to do two things. The first thing I'm going to discuss is why do we even teach addition and subtraction differently? Why do we teach it differently than the way that you learned it? Because several of you said it looks like the way I learned it. And then the second part will be most of our focus for the meeting is what flexible strategies do students see for addition and subtraction specifically? So those are the only two operations we're going to focus on today. So let's get going. The first part, why are we teaching addition and subtraction differently in elementary? Let's address that. So on the screen, I know that you can't see this, but what this is from the Texas Education Agency. It's the math standards or Texas Essential Knowledge and Skills or TEKS that we're expected to teach in grades kinder through 5th grade. And I'm just going to highlight a couple of them. In 1st grade, students are expected to apply fact strategies to add and subtract within 20, including making a 10. So that's a strategy 1st grade is expected to use. In 2nd grade, students are expected to add up to 4 two-digit numbers and subtract 2-digit numbers using mental strategies based on place value and properties of operations. In 3rd grade, students are expected to solve problems involving addition and subtraction within 1,000 using strategies based on place value, properties of operation, and the relationship between addition and subtraction. So you could see students are using strategies to add and subtract through 3rd grade. Now in fourth grade is when the way we learned comes to be. So in fourth grade, students are expected to add and subtract whole numbers and decimals to the hundredths place using the standard algorithm. So when I say that word standard algorithm, what that basically means is we're lining up the numbers. We're stacking the numbers on top of each other. And this is an example of what the standard algorithm looks like. So in fourth grade, students do learn the standard algorithm. And that's what we're expected to teach it in the state of Texas. So that was a real quick overview of why do we not just teach it? And starting in second grade using the standard algorithm, it's because the state of Texas tells us to wait till fourth grade. So we're going to go into part 2, which is the flexible strategies. And before we do, I just want you to keep a few things in mind. The first thing is it is okay to show your students the regular way, the way you learned, and ask your child to line up and stack the numbers when adding and subtracting. No one is telling you that that is a wrong way to teach kids how to add and subtract. In fact, it's a way that was invented because it's very efficient. But we know that students often learn the steps as meaningless procedures, develop error patterns, and require excessive amounts of reteaching. Just like that student in the very beginning of the presentation was struggling, was confused, was making errors, all the things you said. That's what happens when students are just taught the way that we learned too young. We see it all the time. Also, if you'll keep in mind, the understanding that students gain from working with different strategies makes it easier to teach the traditional methods. So the strategies that you're about to learn about ultimately help kids to better understand why that standard algorithm, why the regular way, lining up and stacking numbers works. Also, if you'll keep in mind, we do not expect kids to use all strategies on every single problem. We don't expect the kids to solve a problem 4 different ways or 3 different ways. We do ask that students don't rely on just one strategy because as numbers change, and the problems change, a strategy might be a better choice. For example, if I was to say, what is 1,000 minus 999? Most adults would know it was 1 without stacking those numbers because 999 is 1 away from 1,000. So using that standard algorithm isn't the most efficient way to solve 1,000 minus 999. So that's just an example of that. And also, in order to justify answers, we ask that students show one way to solve and another way to check. So at minimum, we want students to have flexible thinking and have one way to solve and another way to check. All right, so now this is where your paper might come into handy. I'm going to go through 3 strategies for addition. And as I'm going through, I'm going to pause. I'm going to talk about the strategy, show you what it looks like, and then I'm going to give you a moment to jot down any notes you want to remember about each of the strategies. If you've got any questions, if you'll just put them in the chat. I have an instructional coach from Sanchez who's manning the chat, and also Myra to answer any questions that y'all might have. But I'll give you a moment because I know several of you have just joined. So if you want to go grab something to write on, you can do that. I'll just give you about 30 seconds to make sure y'all are ready so you don't miss any of the strategies. Well, I see a request for multiplication and division. Maybe we could offer that later, Myra, Patty. All right, so let's start with the first strategy for addition. So we're going to start with composing and decomposing. So this is the first strategy, and I'm going to show you starting in first grade. So I know we've got some first grade parents out there. So this is how we compose and decompose in first grade with addition. So let's say we have 8 plus 7. We also have what's pictured to the side here are 10 frames. So we're going to build the first add-in, and that's 8. And we're going to use counters to do that. So the kids have a visual representation modeled concretely for them to show 8. Then we're going to build the second add-in, 7, on another 10 frame. And we're going to ask the kids which 10 frame is closer to 10. And the kids should be able to say the one that's red, the one with the red counters, because it's 2 away from 10. And we're going to ask the kid, how many counters do we need to move from the other 10 frame to make 10 on this 10 frame? So we want the kids to see that I can move 2 counters from the yellow 10 frame up to fill up this 10 frame that is missing 2 counters. So when they do that, this is what they've got. They've got a whole 10 frame full and then 5 remaining on the other one. And we would ask the kids, how did you break apart 7 to make 10 with the other added? And we want the kids to say, I took 7 and I broke it into 2 and 5. So they're decomposing that number 7 into a 2 and 5 in order to make 10. How many counters are left on the 10 frame after you made 10 on one of the frames? So the kid should say, I've got 5 left after I moved and decomposed 7 into 5 and 2. And then what is the sum of 8 and 7? Ultimately, that's the goal. We want to know what 8 plus 7 is, and we're using 10 as a friendly number to do that. The kids should be able to see visually, I've got 1 full 10 frame and 5 remaining. So the answer to this, the sum is 15. So if I was to record this, 8 plus 7 is the same as or equal to 8 plus 2 plus 5. So the kids should say 8 plus 7 is 15. So 8 plus 7 is the same as 10 plus 5. So this is first grade. And what you'll notice as I go through this presentation is I'm going to record how the thinking is done on all of these problems. Know that the thinking is not always expected to be recorded by the student. This is just a recording of thinking, and teachers do this a lot. However, we don't always require it for every problem for every student to jot down the thinking. For first grade especially, it would be more manipulating the counters on the 10 frame. So I'm going to give you about 30 seconds to write down anything specific to first grade with composing and decomposing, and then we're going to go up to another grade level to show how this works. Okay, so now we're going to continue composing and decomposing with numbers that are appropriate to second and third grade. So now I've got much bigger numbers than 8 plus 7, because remember in first grade, they're adding and subtracting within 20. So when we get into second and third grade, they're adding and subtracting within 1,000. So the numbers definitely increase. So here we've got 64 plus 32. So the way that we learned back when we were in elementary school, we would stack those numbers and we would say 4 plus 2 and 6 plus 3. That 6 and that 3 have a value. That is 6 is not worth 6 and that 3 is not worth 3. So we really want to make sure that kids understand that. So I'm going to decompose 64 into 60 plus 4, because that is what 64 actually is. 64 is not a 6 and a 4. It's 60 and 4. And I'm going to do the same thing to 32. I'm going to decompose it into 30 and 2. Then I'm going to combine my 60 and 30 to make 90, and my 4 and 2 to make 6. I'm going to join my 90 and 60 to ultimately get the sum of 96. So this is composing and decomposing within 100, which is something we see happening in second and third grade. So I'm going to give you about 30 seconds to just jot down anything you want to remember about this example. Because remember, the whole goal of this session today is for you to be able to support your student when they're working on math at home and they tell you, I don't do it like that. I don't do it like that. You'll have something to refer back to help your student. All right, so let's go to the next one. So now we've got 3 digits plus 3 digit add-ins. So for this example, I'm going to do the same thing. I'm going to decompose 362 because, again, that 3 in this number has a value. That 3 is not just 3, it's 300. So I've got 300 62 is decomposed into 300 plus 60 plus 2, and 294 is 200 plus 90 plus 4. I'm going to join together my hundreds. 300 and 200 is 500. I'm going to join together my tens. 60 and 90 is 150. And 2 and 4 is 6. I'm going to add those numbers together, and I get my sum of 656. Students could also think of this problem this way. 300s and 200s is 500. So thinking about the words, they could say 6 tens and 9 tens is 15 tens. And visually, they could count by tens 15 times. We use manipulatives called base 10 blocks. They could use those to count up 15 tens, but they use what they know about addition and subtraction to 20 to understand 6 and 9 is 15, but I'm talking about tens. So 15 tens is the same thing as 150. And then they add their ones. 2 ones and 4 ones is 6 ones. So that's just another way that kids could think about doing this problem. So I'm going to give you 30 seconds to just jot down any notes you want to from this example. And what I'm about to show you now is another way you could think about this problem. So here's the same problem. 362 plus 94, 294. I'm decomposing the numbers the same way. I'm joining my hundreds. 300 and 200 is 500. But here I'm decomposing my 60 into 50 and 10 because I know 90 is really close to a friendly multiple of 10, 100. So I'm going to decompose 60 into 50 and 10 so I can make 100 here and then add my 4 and 2. So now as a student, I could say 500 plus 100 is 600 plus 50 is 656. So this is just another way that kids could have thought about using composing and decomposing to find the sum of 362 and 294. So again, I'll give you about 20 seconds this time, just because this is a different way of doing that same problem we did before, using composing and decomposing. All right, let's move up to 5th grade. Oh, before we move on, I forgot I had one little animation here for y'all to see. So again, this is explaining what I explained. 300s and 200s is 500. 60, again, can be decomposed into 50 and 10 to make 100. And 100 plus 50 is 150. And then 2 ones and 4 ones is 6 ones. So that's just the thinking that kids could use to describe how they decomposed and recomposed or composed to find the sum. All right, so now let's go to 5th grade. So 5th grade, we have fractions and we add them when they have unlike denominators. So back in school, you might remember noticing that the two denominators were different, knowing you couldn't add them, listing out your least common multiple, then making equivalent, lots and lots of steps. And many of you might have been really good at those steps. I was, but after seeing this way of thinking, using composing and decomposing, it actually is very helpful to understand this strategy as opposed to a bunch of steps that maybe could get forgotten and then you'd have to go back and Google the steps or watch a YouTube video. So let's look at how composing and decomposing can be used with fractions. So I'm going to decompose 3/4 into 1/2 and 1/4. So some of your students might not understand where that 1/2 came from out of 3/4. So where is that 1/2 and 3/4? How did you decompose 3/4 into a half? We show visuals to kids to help them see that. If I start with 3/4, I know that half of this square is represented by 2/4. So 2/4 and a 1/4 would represent a half. But the reason why I want to pull a half out of this fraction is because I want to make wholes. When I'm adding and subtracting fractions, 1/2 is nice to have to add and subtract. So now I've got 1/2 plus 1/2 plus 1/4. And so my sum to 1/2 plus 1/4 is 1 1/4. So I've decomposed 3/4 in a way that helps me to make 1/2. Let me show you another way you could think about this problem. So again, the same fractions, 1/2 plus 3/4. Kids could say 1/2 can be decomposed into 1/4 and 1/4. They could say 3/4 can be decomposed into 1/4 plus 1/4 plus 1/4. So I'm decomposing each of those fractions into a unit fraction. And then I combine all those fourths, 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4 to get 5/4 or 1 1/4. And again, a visual is there. We use them as much as we possibly can to help students with not just fractions, but any operation. Visuals are so helpful to understanding the abstract nature of equations. So this is another way that students could think about adding, using composing and decomposing, specifically with fractions. And again, this is something we do in 5th grade. And some of you junior high parents, this is something they're still doing in junior high as well. So I'll give you about 30 seconds to jot down anything you want to remember adding and subtracting. I'm sorry, just adding. We haven't got to subtracting yet with fractions using composing and decomposing. All right, so we're going to move on to our second strategy for addition, which is compensation. And what I want to do is just give you a glimpse into how we teach this initially in 2nd grade. So compensation is a strategy we teach. And I want to also say that students don't have to identify that I'm using specifically compensation to solve this problem, but they more importantly is that they understand that it works. And so here's a simple example of compensation. And again, this is how we teach it in 2nd grade. So imagine that you have 2 baskets of apples. One basket has 9 red apples and the other has 3 green, and that's pictured visually for you. If I need to determine the number of apples I have in both baskets, I can move 1 green apple from the basket and place it with the red apples so that one basket now has 10 apples and the other basket has 2 apples. So there's a visual of that. So all I didn't eat any apples. I didn't throw any apples on the floor. They're all still in baskets. I still have the same number of baskets. I just moved one of the green apples with the red apples so that I had 10. And we know 10 is a friendly number for students to work with. So 10 combined with, let me go back. Let's see. Lost my place where I was. Okay, so now I have one basket that has 10 apples and the other basket has 2 apples. 10 combined with 2 is 12. The problem 9 plus 3 was made simpler, 10 plus 2, but the total number of apples wasn't changed. So this is initially how it's taught. We use some type of object to visually show kids this. It's not just pictured like I'm showing you. But I wanted y'all to have an understanding that we don't just teach kids to do this and then do that. We try to give them a reason why it works using something that they can actually see and touch. Okay. So now let's practice using compensation. So again, this is about 2nd or 3rd grade. We're adding and subtracting again within 1,000. And what I would do here is I'm thinking I want to make 294 friendly. And I know 294 is really close to 300. And that's hopefully what the students would notice. One of these numbers is really close to a friendly multiple of 100. So in order to make 294 300, I have to add 6 to that number. And so just like the baskets, if I'm going to add 6 to my basket with 294, I have to take 6 apples from my basket that had 362 apples. So it kind of looks like a give some to one, take some from the other, but we don't teach kids that. We relate it back to something that they can remember doing, like with the apples. So The first thing I'm going to do is subtract 362 minus 6, which is hard for some kids. Whenever they have to cross a multiple of 10 or 100, they struggle. So using a number line helps them to make it visual. So you can see how decomposing is used. 362 minus 2 gets me to 360, and then minus 4 more gets me to 356. Sometimes it's not as easy for them to do, so a visual does help. And then 294 plus 6 is 300. I color-coded to hopefully help y'all visually see how this works. So now I'm going to add 300 plus 300, 50 plus 0, and 6 plus 0 gives me a sum of 656. So this is compensation using addition with what we teach in 2nd and 3rd grade. So again, I'm just going to give you a moment to jot down anything you want. I'll give you about 20 seconds because I feel like you're getting the hang of it. It might not need as long. And you might be jotting as I'm going to. If you need more time, please put it in the chat. I don't want to talk too fast or give you too much information that you don't have enough time to process. All right, Erica, thank you for that. All right, so let's go to fractions. So we're jumping from 2nd to 3rd grade back into 5th. Again, we've got fractions with unequal denominators. So let's think about compensation and how that will work. So I'm looking at this problem and I see 7 2/3 is close to a whole. I know that if I add a third to 7 2/3, I'm going to get 8. And I know when I have whole numbers, it's easier to work with fractions. So if I'm going to add a third to 7 2/3, I have to take away a third from 3 5/9. So again, I'm going to make this as visual as I can for students. If I have 3 5/9, the only thing I'm modeling here is 5/9. I have to think about what is equivalent to ninths if I have 3 ninths. And I could see 1/3 is the same thing as 3 ninths. And if I take away 3 ninths, which is the same thing as 1/3 from 5 ninths, I'm left with 2 ninths. So I'm making that visual. I'm showing how the fractions are equivalent, and then I'm showing the subtraction. So then I've got my whole that I've added 2/3 and a third. So I've got 7 plus 1 is 8, plus 3 2/9 gives me 11 2/9. So using compensation can also work with 5th grade and fractions. So again, I'll give you about 20 seconds to note down anything you'd like to remember from using compensation with fractions in 5th grade, and we'll move on to our last strategy for addition. All right, so we're going to do compatible friendly numbers. So this is our last strategy for addition. We're going to do 362 plus 294. We're going to use a number line to add because kids can jump whatever they feel comfortable jumping and whatever is most friendly to them. So when students are doing this, they can make jumps of a variety of things. So I'm going to show you 2 different ways that this problem can be done using compatible friendly numbers. So I could start with 362 and I'm going to add 200. If I add 200 to 362, I land on 562. So I've added 200, I still have 94 to go. So now I'm going to add 30. The reason why I'm not adding more than 30 is because I'm getting close to 600 and things kind of get hairy when I get close to that multiple of 100. So I'm getting as close as I can to it without going over. So I added 30 because I know 6 tens plus 3 tens is 9 tens. So now I've added part of my 94, but not all of it. I've decomposed again. So now I'm going to add 10. The reason why I slowed down on the amount that I'm adding is because kids can use their fingers if they want to at this point to get from 592 to 602 by adding 10. They can add 10, and it's not so cumbersome to have to do. So I added 10, so I've added 40 of my 94. Now I'm going to add 50. 602 plus 50 is 652. So now I've added 90 of my 94. So I've got 4 more to add. to land on 656 because 652 plus 4 is 656. So depending on what kids want to use here to jump is totally up to them. Teachers validate a variety of strategies to get to the same answer. We actually encourage students to try to think of another way to prove that their answer is correct. So this would be one example of how compatible friendly numbers could work. The second example I'm going to show you is very different. So I could add 300 because, again, I know 294 is pretty close. But if I add 300, I've added more than I need to add because it only was 362 plus 294. So if I add 300, I'm at 662, but I have to go back 6 because I added 6 too much. So if I take away 2, I'm decomposing that 6 because I'm, again, getting close to a multiple of 10, which I have to be real careful when I'm there. So 662 minus 2 is 660. And then I've still got to subtract 4 more because I'm decomposing the 6 extra that I jumped to get to my actual sum, which is 656. So again, 2 different ways that kids could think about adding and subtracting using compatible friendly numbers and using a number line. So I'm going to give you about 20 seconds. Just jot down anything you want to remember about this strategy. All right, so here's another example of how compatible friendly numbers could be used with 4 two-digit add-ins. So I've got 24 plus 32 plus 16 plus 18. And one student might think this 4 and 6 makes 10. Students compose 10 in kindergarten. So they might see that 4 and 6 make 10. And I know that I've got 2 10s and 1 10. So that's 30, 3 10s, plus a 10 is 4 10s. So here in this example, students are looking for numbers that go together to make that friendly number 10. They might see here for 32 plus 18, I see an 8 and 2, and I know together that makes 10. So I've got 10 there, added with 3 10s and 1 10. So that's 4 10s or 40, plus a 10 is 50. And then if they add 40 and 50, they get to 90. So this is another way of using numbers that compose a 10 to think about how they could use addition. So just another example from 2nd and 3rd grade and really thinking about numbers that are friendly and composing 10. All right, let's get to 5th grade and fractions and thinking about compatible numbers. So I have 8 and 2/5 plus 1 and 4/5. What I'm going to do again, every time I'm working with fractions is try to make a wholes. So I know within 4/5 I have 3/5 and 1/5. So this is decomposing my 4/5 into what I know will work with 2/5. 2/5 and 3/5 give me a whole. So as I jot this down, and again, this is an example of the notating that teachers might do, not necessarily that kids would be expected to do, but I just wanted you to see the thinking that's involved here. If I add 8 and 1, I've got 9. I add my 2/5 and 3/5, I've got another whole, and then I have 1/5 remaining. So 9 and 1 is 10, plus 1/5 is my 10 and 1/5. So this is how compatible friendly numbers work with addition in 5th grade. So again, if you just want to jot down anything you want to remember about this specific example, because I know we do have some 5th grade parents. 4th grade parents, this example does have common denominators. In 4th grade, they do add and subtract fractions with common denominators. So they could very well have an example like this in 4th grade as well. But typically in 4th grade, they're supported with a model. In 5th grade, there isn't always a model to support them. Okay, so we've covered addition. And here's an example of a problem that students might see in 2nd grade. So when we're working through problems, we use a problem-solving model, and this comes straight from our math standards that we're expected to use and incorporates analyzing, planning, and solving, and justifying and evaluate reasonableness. So the first thing kids are going to do is read the problem. So Joel is baking cookies for a party. He needs to bake 148 chocolate chip cookies. He needs to bake 36 more sugar cookies than chocolate chip cookies. How many chocolate chip cookies and sugar cookies does Joel need to bake all together? So kids would read the problem and they would ask themselves, what do I know? So I know that he's making 2 different kinds of cookies. We don't want kids to say add, subtract. We want them to actually talk about what's happening in the problem. So we know that Joel's making 2 kinds of cookies, and we know that he's making more sugar cookies than chocolate chip. If the kids can tell you that, that's fantastic. Okay, we're not always looking for a operation when we're analyzing. And then what do I need to know? I need to know how many cookies he's making all together. And then is there a hidden question? So this might be new, something new that your kid's talking about, because ultimately there is a hidden question. I don't know how many sugar cookies that Joel needs to make. I have to answer that too to find the ultimate answer. I know he's making 148 chocolate chip cookies, but how many sugar cookies he's making, I don't know. It's not 36 because it's 36 more than 148. So that's that hidden question I have to answer before I can get to my ultimate answer of all together, how many cookies did he make? So then I'm going to represent the problem. When I get to plan and solve, we ask the kids to represent. So make this problem visual. And in 2nd grade, up through elementary and even into junior high, we ask the kids to use a strip diagram. And what a strip diagram is just a rectangular model to show what's happening in the problem. So you could see I have my 148 chocolate chip cookies. I have my sugar cookies represented in green. So I know that there are 36 more sugar cookies than chocolate chip. So you could see, kids can see visually what they need to do to figure out that hidden question, how many sugar cookies are there? So what I want to ask y'all to do is I'm just going to give you about a minute, is to try to use one of the strategies that you've learned for addition to solve this problem. So we've learned compensation, we've learned composing and decomposing, and we've learned compatible friendly numbers. So based on your notes and the examples that you've written down, or just what you're thinking right now, and remember, stacking the numbers and adding them up is okay. I just encourage you to try to use another strategy that you've learned today that your kids are practicing at school. So I'll give you about 1 minute, and then I will show you an exemplar. I will show you an example of what this could look like in case you're not sure what to do other than stacking the numbers. So try something out. Just work it out. I'll give you about 1 minute. I could see somebody shared in the chat. I saw that come across the screen. Thank you for doing that. All right, let's compare your work to what I have. There's a couple questions here in this justify, evaluate reasonableness box that we ask kids. How can I check my work? And how can I prove my solution answered the question? So again, I'm trying to figure out how many cookies altogether. So here's a strategy that can be used. So this first example is using compensation. And again, an exemplar is not the right way. It's just an example of a right way that students could have solved this problem. So I think 148 and 148 are really close to 150. So I added 2 to both of those numbers to make them friendlier to work with for me. If I do that, I have to take 4 away from my other number. So 36 becomes 32. I add 100 plus 100 was 200, and 50 plus 50 is 100. And then I have 32 to add on, 332. So that's one way that you could use one of the strategies, compensation, to work this problem. Here's another way. I used a number line and I color coded my add-ins. So I started with 148. I added 148. You could see with the blue jumps, and I added 36. And again, landed on 336. That should be 332. We teach kids that mathematicians make mistakes. So I apologize for that error. We'll fix that for Thursday. But these are 2 different ways that you could solve this problem using the strategies that we've learned today. All right, so let's go on into subtraction because you're here for subtraction too. So let's talk through the three strategies, and they're the same strategies: composing and decomposing, compensation, and compatible friendly numbers. So let's start with composing and decomposing. So now we're subtracting. So it's going to be a little different. So you got to switch your brain, but it still involves decomposing your numbers. So I've got 786 minus 523. I'm decomposing 786 and 523 into the values that are represented by each digit in that number. So now I'm going to subtract. 700 minus 500 is 200. 80 minus 20 is 60. And 6 minus 3 is 3. I'm going to add up those partial differences to get my difference of 263. So hopefully you see how composing and decomposing is very similar to what we did with addition. We're just subtracting now. We're still decomposing the number, but then we're subtracting. And then we're adding up what we subtracted to get our ultimate difference or answer. I'm going to give you all about 10 seconds, so a little less time because I want to make sure we have time at the end for some questions and answers if you have them. But I could talk about math all day, but I know y'all might not want to. You might have other things to do. Okay, so here's another example. And this is where it's a little bit trickier for kids. We have regrouping involved. So the kids should see that 400 minus 200, yep, I can do that. 90 minus 60, I can do that. But 4 minus 7 as a third grader, I don't know how to do yet because I haven't learned about there's negative numbers. Okay, so they should see that this is an issue. I can't subtract 4 minus 7. We don't want kids to just say that's 3 because it's not 3. So what I'm going to do is I'm going to decompose 94 a different way. I'm going to change 90 plus 4 to 80 plus 14. And we want the kids to see that 400 plus 80 plus 14 is the same as 494. I haven't changed anything other than just the way I'm representing this total. I've decomposed the number a different way so that I can subtract. 400 minus 200 I can do. 80 minus 60 I can do. And 14 minus 7 I can do. When I add up those differences, I have 227. So kids start in first grade with decomposing a number to 120 in more than one way. So they don't use it to do what we're seeing on the screen, but they use it ultimately so kids can be able to do this after first grade. So this is just an example, and this is typically where things get a little harder is when they have to regroup or in our day, borrow. This is where kids start struggling with subtraction. So here is a way to use composing and decomposing is to just decompose what's there another way so that you can subtract. And kids do this with base 10 blocks. They do this with concrete models. They touch it and they break apart tens and hundreds so that they can see that 94 is the same as 80 and 14 or 8 tens and 14 ones. Okay, let's move on to decimals. So this is fifth grade. They have to add and subtract positive rational numbers. So that includes fractions and decimals and whole numbers. So this is an example of how composing and decomposing can work with decimals. So I decompose 37 and 6/10. When I say 9 and 1/10, that is a decimal. It's also a fraction. Again, I could see that 7 minus 9 causes a problem. I can't subtract 7 minus 9, but I can decompose 37 a different way so that I can subtract. 37 is the same as 20 and 17, or 2 tens and 17 ones. And then I could subtract to get my difference. So using that same strategy we initially taught in second, third grade to work with the number types that we're expected to do as a fifth grader. So that's composing and decomposing. Hopefully you're kind of jotting notes as I'm going through because I know we're getting closer to the end time. So I want to just keep moving to get through all of the strategies for subtraction. So the next one is compensation. Again, just like with the apples, when we teach compensation, we want to teach visually why something works. So here's an example of a problem, 50 minus 23. If I place both of those numbers on a number line, 50 and 23, the distance between those numbers is represented by this bar, 27. There's 27 between 23 and 50. If I subtract 1 from 50, so you can see I just subtract 1 from 50 and 1 from 23 to get 22, a new problem is made. So I no longer have 50 minus 23, I have 49 minus 22. So the distance between 49 and 22 is the same as the distance between 50 and 23. So just like with the apples with addition, we use a number line to show kids why compensation works, because you're really looking at a distance between numbers. And if you add 7 to both numbers, the distance should stay the same. If you subtract 3 from both numbers, the distance is still the same. So whatever they do to each number, it keeps that distance the same as long as both that same thing is done to each of the numbers in the problem. So let's look at what this looks like. So here's 494 minus 267. Whenever I'm having to subtract, so here's that same number example, I should see that 4 and 7 causes the issue. That causes the regrouping, the need to have to borrow. So I'm going to add 5 to 494 because when I add 5 to 494, I get to 499. And whenever I have 99s, any 9s in subtraction, I don't have to do the regrouping. So I'm not going to get to 500 because then I'll have zeros. And whenever I have zeros in subtraction, that causes problems. So I'm going to make it 499. But if I do that, I have to do the same thing to my other number in the subtraction problem. So I'm adding 5 to each of those. Again, the distance between these two numbers is not changed. So 267 plus 5 might cause kids some problems. So again, using a number line helps them to do that. I'm going to jump 3 to get to 270 and 2 more. So I decomposed 5 into 3 and 2 to get to what 267 plus 5 is. And then I'm going to subtract 400 minus 200, 90 minus 70, and 9 minus 2. So the need to regroup is no longer there. And I get my difference of 227. So that's an example in 3rd grade of how compensation can be used. I know most of you probably have a phone. If you're on your computer, you could even just take a picture of this example. If you feel like you want to write it down and you're not getting enough time to write it down, maybe that would be an easy way to remember what is being shown. And we're also recording. So I know that this will be available for you to watch later if you wanted to just refresh yourself on any of these strategies. Okay, so 5th grade. What does compensation look like in 5th grade? So here is 60 minus 18 and a half, a very challenging problem for our 5th graders to have to do because it involves regrouping and renaming 60. And so making compensation a strategy really does help. So I'm going to add a half to each of these. Why would I add a half? Because 18 and a half gives me a whole number. Remember, whole numbers are easier when we're working with fractions. So now I have 18 and a half plus a half. So just a visual of that gives me 19. So now I have 60 and a half minus 19. And I know I've got this half here, but if I do 60 minus 19, I might need a visual there to help. Again, 60 minus 10 would get me to 50, 50 minus 5 to 45, and 45 minus 4 to 41. 60 minus 19 is 41, plus my half that remains gives me my difference between 60 and 18 and a half. So this is an example of compensation. I just want y'all to hopefully see that these strategies that we're teaching kids in 2nd grade don't expire. They continually work all through elementary, and then they continue to work into junior high. And all of these strategies are in our curriculum. Teachers are teaching them. Your kids are learning them. So these are just strategies that I know I want y'all to have some familiarity with so that you can help your kid if they need help. And they're saying, I'm using compensation or I use a number line. And it'll just kind of give you some understanding of what they're learning at school. So our last strategy for subtraction is compatible friendly numbers. And again, I used a number line with addition, and I'm going to use a number line with subtraction. And I'm going to tell y'all, this is my favorite of all the strategies I'm going to share, the best for last. All of them are great, but this one is really my favorite because I know how much kids struggle with subtraction. Okay, so get ready. This might blow your mind, maybe. If you're a math nerd like me, it might. Okay, so 494 minus 267. Students' thinking could include, I'm going to think addition, and about the related fact 267 plus something plus a number gives me 494. Okay, so I'm going to think about addition to do subtraction. So I'm going to start with 267 because, again, I'm thinking about this related fact. And I'm going to add on to 267 until I land on 494. So 267 plus 200 is 467. Plus 10 is 477. So I'm just adding whatever I want to, whatever jumps I want to do until I land on 494. Plus 10 more is 487. If I do another jump of 10, I'm going to go over. So I'm going to decrease my jump. I'm going to add 3 to get to a friendly number, 490. And then I'm going to add 4 to get to 494. So where's my answer in all this? I'm going to go back to my related fact. 267 plus my jumps landed me on 494. So if I add up my jumps, 200 plus 27 is my answer. Guys, this is a big deal. You don't have to subtract to subtract. And that to me is amazing because kids really do struggle with subtraction. They can think addition. You don't have to subtract to subtract. Remember that. That's a big deal. And this is, like I said, one of my favorite strategies because I know how much struggles kids have with subtraction. They could think addition and they could use a number line. Okay. Sorry, I got real excited. Okay, so then another example here of compatible friendly numbers is just decomposing to what would be friendly with another number. So here at 46 minus 18, you could see how 18 was decomposed into 16 and 2 because taking away 16 from 46 is friendly. So this is just another strategy of how you can decompose into numbers that are friendly to subtract. And so I don't want to leave you without touching on fractions. So here is 5 2/5 minus 3 4/5. Again, I'm going to think of that related addition fact. 3 4/5 plus what number gives me 2 5/5. I'm going to draw a number line. I'm going to start at 3 4/5, and I'm going to jump until I land on 5 2/5 with whatever jumps that make sense to me. So 3 4/5 plus a fifth lands me on 4. 4 1/2 gives me 5. And then 5 2/5 lands me on 5 2/5. And again, where's my answer? It's in my jumps. I have 1 3/5 is my answer to 5 2/5 minus 3 4/5. Again, I didn't subtract to subtract. I thought addition. Okay, so last but not least, we want kids to apply all these strategies to the problem solving that they have to be able to do to apply their learning. So here we've got a problem. Again, we're going to use the problem solving model to think through it. Last month, the school store sold 107 t-shirts and 88 sweatshirts. How many more t-shirts were sold than sweatshirts? So I'm going to ask myself, what do I know? I know there's a store that's selling at school that's selling shirts and sweatshirts. What do I need to know? How many more t-shirts were there than sweatshirts? There's more t-shirts. How many more? How many extra? And then is there a hidden question? In this problem, there isn't. I'm really just looking for the difference between those two types of shirts. So how can I represent this problem? I'm a second, third grader, fourth grader. I'm going to use, or fifth grader, or even in junior high, a strip diagram. Here's how it's modeled. I have 107 represented by my orange rectangle and 88 sweatshirts represented by my green. And the more that are t-shirts is represented by that question mark. So I know that there's more t-shirts than sweatshirts. So the kids should visually see that adding 107 and 88 does not make sense. This amount here is smaller than 107. So I'm not going to add to 107. So now, again, I'd like you to just try to use one of those strategies. Use compensation, use composing and decomposing. Use a number line. Think about how you could not subtract to subtract to use a strategy to solve, and then try maybe a different strategy to check your work. And I'll give you about 1 minute to do that. All right, so I'm going to again show you an exemplar. An exemplar, again, is just one way that you could think about, one right way that you could think about solving this problem. So I use my number line, my compatible friendly number strategy, where you don't have to subtract to subtract. So a number plus 88 is 107. So I had 88 plus 2 to get me to my friendly number, 90, my multiple of 10, plus 10 is 100, plus 7 is 107. And my difference, or what I add to 88 to get 107, is in my jumps. So 10 plus 7 plus 2 is 19. So that's one way. Another way is to use composing and decomposing. Here, I knew that there would be some regrouping needed. So I decomposed 107 instead of 100 plus 7 into 9 10s and 17 ones, or 90 plus 17. And then I could subtract 90 minus 80 is 10, and 17 minus 8 is 9. And then I could compose my differences to get my answer, 19. So 2 ways that you could thought about figuring out how many more t-shirts there were than sweatshirts on that previous problem. So hopefully these kind of matched. You might have come up with something different. Your jumps might have looked different than mine, but these are some examples of what your students might have done to solve that problem and then to check their work. All right, so our ultimate goal today for this session was to deepen your understanding of addition and subtraction strategies to support your elementary student by using flexible strategies. Hopefully you feel like we met our goal. That's always what I intend to do when I work with teachers and when I work with anybody, parents, the instructional coaches. Hopefully you feel like you learned a lot. But if you haven't got your questions answered in the chat by Myra or Patty during the session, feel free to hang on for at least 5 more minutes. If there's anybody who has any questions that they'd like to ask, feel free. But I do appreciate your time. Again, thank you so much for giving up your hour lunch break, or just an hour of your time that you had today to spend just learning about math. I appreciate it so much.